Hi, hi everyone. It's been almost a month. Yeah, let's start quickly. This will be regarding to Kafka, continuation to my previous stream, which was typically a prerequisite to Kafka, and this is my second stream in that series. Yeah, and I also got a feedback that um, the streams are a bit longer from many people, many of my friends. That's because I don't know. I never think like that. I never decide and do the stream like it should be 1 hour. It should be half an hour. I let it go naturally because time is never a constraint because I do this mostly on weekends. And yeah, I think the concept should be clear, right? To understand the tools or things properly, concept should be clear. Yeah, I'll try to keep things as crisp as possible. This is just an experimentation video. Doesn't mean that doesn't have any content. It has content, but I'll try to restrict myself to 25 minutes to see how much I can explain in 25 minutes. Yeah, let's start. As the title says, you can see that this is the terminology and introductory video. Mainly I'll discuss about last time you just see why we need Kafka. Now we'll see what are the basic terminologies that we use. I mentioned the term basic. There are many more terminologies that we'll get as I'll be exploring since I'm also learning in parallel. Yeah, let me share my screen. Um, we'll see first what are terms, then we'll see one by one. When I draw from the picture, I'll be drawing a picture now. Kafka cluster, broker. Oh, Bapre. I think at least listing so many. We won't be discussing all this. As I mentioned, that this is just a basic technologies. Topic, partition, replica, logs, leader, producer, consumer. Um, just for the sake, just let me add offset also. Yeah, after this, even I don't know from here what is this consumer replication factor and stuff. Yeah, let's not go to that. First, let's discuss Kafka cluster. Let me draw an image in XLA draw, and I'll show you how cluster and stuff will be. Okay, I think I was doing some data structure questions. So, how to go to a new one? No, this is magnifying. No, not this one. What? How come I'm getting? Okay, if you see, this can be used as unlimited. Huh? Okay, got it. So let's not waste much time as we have very less time. Let me quickly draw. A, Okay. Mm, 1 second. Okay. Let's place this here. And now let's draw this one. Again, copy, paste, paste. Okay, my bad. Let's place it here. Let's place this one here. Yeah. Um. Let's draw two more things here. Here three. Yeah, I'll tell you what are these boxes. Let me quickly draw them. Yeah. Um. You know what? I don't know this. Yeah, I don't want this. Sorry, it's not. I don't know this. Yeah. Um. This is a Kafka cluster. You see the bigger box here, right? This is a Kafka cluster. The outside one is broker one. Let me put it inside. And this is topic A. And inside one is partition A. And the same thing will apply here. This is broker one. This is topic A. And this is partition B. This is partition B. Let's edit this as topic B. And let this keep it as broker 2. Yeah, this is producer 1, producer 2, consumer 1, 2, 3. Yeah, if you see this okay, first, where does Kafka resides? Kafka, so when an application generates an event, which is a change, when events are generated, it should be stored in Kafka. So now forget, don't think about what is this Kafka and what's the point of storing. But if I'm generating an event, I should store it somewhere, right, in order to process it later. So I'll be, when I mean I'm storing it in a Kafka, what does it mean? It's a memory. What does that? It stores in a memory. Kafka stores it in memory. It doesn't store it in itself. Whatever storage space is a memory. But where does it store? Uh, is it RAM or is it ROM? I think you are correct. It is wrong. Oh no, it's not. Nothing to think here, because RAM is a temporary, and since ROM is permanent, we will be storing on that. So what do you mean by, before letting know what is Kafka cluster? We'll see what do you mean when you create an instance of Kafka cluster. Let's follow AI. So when I said I have created a Kafka cluster, so that means I asked for a piece of RAM storage because this is where I'm storing my events or whatever from the cloud provider, whatever, doesn't matter. So this means I ask for a place of ROM storage. So when I say Kafka is storing, you are sending it to Kafka, it is storing in actual disk. So there should be some code written or a program written in the piece of Kafka so that it does this form of physical events and taking them and storing into the disk. So it's a code. It's written in Java if I'm not wrong. Code is written in Java to take these events. So here in point number 6, I mentioned logs, right? So what people usually think is logs is like something like errors or whatever that comes when you run your application. That's a true, but that's called as application logs. This is called as I don't know, event logs or something. But the logs that mentioning, I'll be mentioning from this video means an event. Log is an event or a message. I'll be writing here. The one logs which you know, that's also true. That's specifically called as application logs, and these logs are different in the Kafka terminology. So yeah, where are we? When I ask for a piece of RAM, they'll allocate a RAM. But in order to store the event that you produced, it has to be written into the RAM on the disk. Means the code has to be written to take care of those events. So this is nothing but a cluster. The cluster has this part of code. So Kafka has brokers. Brokers are like which is equal to servers. So the input to that server is the message, and the action or the output done by the server or broker is to write to the disk. Uh, Whatever you create in Kafka will reside in the Kafka cluster. So if you see this big color thing, I don't know which color to draw. Yeah, I think this is good. This big color thing that you are seeing in blue color is a Kafka cluster, inside which there are multiple brokers. I'll also tell you why the broker name of these two are same and this is different. So yeah, this is what you mean by when you have a Kafka cluster. A Kafka cluster um, is a combination of multiple brokers or servers that takes up a task and write to the disk space or whatever. So when you generate, yeah, I think I already said the definition of broker. Broker is nothing but broker is nothing but a server which gets action to store a event or log and which gets which has to store in event or log and perform action to do same. So this is broker. A Kafka cluster may have multiple brokers, right? A Kafka cluster might have multiple brokers. Not might have. Yeah, it might have. It's up to you. It's up to you how you create your instance, Kafka instance. Forget all these words, the instance and the word. Since I'm a bit aware, I think 2 weeks older. In this particular 1 month, yeah, not 2 weeks. I'll be maybe for the newcomers it will be difficult like what is instance and something like that. But just stick on to it. You'll get more slowly. Topic. Mm. Already AI is suggesting a lot of things. Yeah. So yeah, topic is, so when I say messages, right? So if you see WhatsApp, there are tags. Okay, a better example is a mail. If you see mail, you will get emails, but there are three category of emails, which is nothing but primary, promotions, and social media, or shopping, whatever. I think social shopping comes under social media. So your message mails are categorized into three categories, under which the incoming mail will come depending on how it categorizes, right? That's again ML thing. So yeah, topic is nothing but category of events. So yeah, so let's say if a topic name is um, weather, the producer, uh, the producer who is connected to this, who is subscribed to this topic, will produce the messages only regarding weather, messages that that signifies or that tells about weather. uh, that's what it means when I say category. So yeah, example, as I said, producer pushing rocks regarding to weather data into weather topic. Yeah, yeah, you can have multiple topics in your cluster. If you see in this diagram, I have two topics, topic A and topic B. So it's up to you how many topics you can create, and there are some trade-offs. It's not like for everything I keep creating a topic. There are trade-offs, and yeah, even I'm exploring on that aspect. We'll discuss slowly. Let's not rush. And partition. What is partition? Partition is nothing but a subcategory of topic. Um, yeah. So this is for scalability aspect. So when you are appending to the, so think of this, right? How do you write things to a disk? So you write things to a disk in terms of files. So it's a file operation. um, when you have a huge a topic, maybe spread across some hundreds of megabytes, so 500 MB or something, you cannot keep adding to the same topic because of so many reasons that we'll discuss. And to make the life of the our programmers easier, they again divided a topic into set of subtopics called as partitions. If you see, for these two, the topic name is same, but the partition is different. Partition A and partition B belongs to same topic. Yeah, a topic can have one or more partitions, which will be writing messages. So uh, they don't need to be always like producer one and producer two keep appending messages to the topic A. Instead, they can append messages to partition A and partition B. So let's say they are getting some thousands of messages. Doesn't need to wait one by one. It can keep whatever the offset is free here, whatever the position is free here. It can keep appending messages, keep pushing messages. The end, what actually matters is message should go to right topic. Partition is just for it doesn't signifies uh, until we talk about scale or more consumers, but I'll tell you. So yeah, now for now you can imagine partition is one or two, more than one partitions can combine to result a topic. Fifth one, replica. So is a replica is nothing but copy of a partition. Partition. So why do we need copyright? Kafka, they claim that they are highly available. It's a highly available tool. So okay. So since I am working with the disk, so because of some reason, one of my broker which does inserting and fetching from the disk, one of my broker fails. So what if my broker fails, the request doesn't go to partition because it has to read from this partition. If my broker itself fails, the request coming to this broker um, will not um, will not be addressed because this broker is down, which is the server which is doing the task is down. I cannot do so. And if something this got corrupted, this partition data, the data which is in this partition might also get lost. So what we can do is what Kafka does is it's a very beautiful concept of called as a replica. So they keep this partition A's data. Okay, my bad. They keep multiple. They keep multiple. One second. They keep multiple replications or copies of same partition, and assign it to different brokers. So let's say if broker one fails, and Kafka, when Kafka is getting a thing to a different broker, some other broker will pick it, maybe broker two, and broker two has partition A under him, which is a copy of partition A, which does the same action. So availability is more. And yeah, in that case, this partition where the original data partition is called as leader, and these are called as replicas. There is a factor of that, and there is a definitely trade-off of these. How much you should keep ideally? What is the suggestible value of a replica? How many replicas of a partition you can keep? Some things like that. Yeah, we'll discuss that slowly in later videos. And replica is nothing but a copy of partition that I just now told. Sixth one. Sixth one is logs, events, or messages that I told. Anything change in its application that brings up a change from user action is called as an event or a message or a log. So a user click on a message, and the click has to be studied or processed, generate an event from that click and store it. That's a log or whatever is an event, right? Leader, I have told, that's the main copy of a partition is called as a leader. Producer, consumer, and offset. So producer is nothing but who keeps pushing data to these, and consumers are Kafka clients which consume data from this. So remember this. I think if I am not wrong, let me confirm once. Uh, in Kafka, a consumer is subscribed to a topic or a partition. So when two consumers are consuming from a topic which has three partitions, Yeah, I'm right. So when a consumer, when you write a Kafka application, right, with the consumer as a consuming thing, any of the language, so you can subscribe to a topic saying that my consumer will read messages coming to these topics. Maybe the consumer one and consumer two will be subscribing to topic A, and consumer three will be subscribing to topic B. Topic one, topic two, and this will be subscribing to uh, topic B. So when I say consumer is consumer to one topic, so if there is no partition, assume there is nothing called as partition. There is a big chunk of okay, how to hide this? Uh, so this is topic without partitions, right? So when I say topic without partitions, messages will keep coming, and two consumers consume to same topic, and if they try to read message, they end up reading same message at the same time, or there is something called as race condition. In order to stop that, because we want high level of parallelism, we cannot handle the race conditions. It's not a good idea, because once the race conditions comes, the concept of locks comes and things like that comes, deadlock, prevention of deadlocks, all these things to come. In order to, this is a very quick, right? They tell, uh, Kafka claims that they are very speed, they are very fast. If things like this will keep up the hold of the system slow. So yeah, that's the need of the partition, and partition is a subtopic. And again, as I said, in order to avoid the race condition, no two consumers should be consumed from the same partition. And if there is a big topic and there are three partitions, and if there are four consumers, then broker is a smart enough, Kafka broker is smart enough to understand that the load will be should be distributed evenly among to the consumers. So in usually what happens is, consumer count is very less than partitions. So this means, more than the number of consumers, partitions will be there. So in that case, a consumer can consume from two different partitions. Consumer can consume messages from two different partitions, and no two consumers can consume from the same partitions. There are some rules, and there is a concept of consumer bro- consumer group that I'll discuss in the next stream. Yeah, and coming to this offset, I think offset will be good when I discuss about the rules, like uh, two consumers should not consume from same partition or something like that. There are some things like that. If I discuss that, it makes more sense at the offset. Yeah, yeah, I think this is the main thing. So this is a small hook here. When I say, if we are dealing with Kafka, we are dealing with hardware like the disk or drive, whatever. So that's ultimately a disk operations, right? Which is slow. That is why that's the whole point of being having RAM, random access memory, uh, which is fast, quicker than the disk. But here, since we need to store events for future processing, we need um, we need some disk space here, and you can choose. I think, which one is faster, HDD or SSD? Yeah, you can comment that down. Yeah, I read the answer. I don't know the answer. I read that in a book. Yeah, you can comment down the answer. Which is faster, SSD or HDD, for reading? And yeah, disk throughput matters. So it's not only about how much space you are doing, how much topic, how many topics, and this. And what actually matters is your disk is having the enabled the ability to give fast IO, fast input output, because the broker is doing the same thing. It will be reading from that file which is located in your disk, something like that. And yeah, I think we are good. That's it. For this stream, we have covered the basic terminologies. I think some 10 terminologies. More are there. I'll keep discussing in upcoming streams, and yeah, I'll try to share this, or you can find in any of the. If you can simple Google or ask ChatGPT. You can get it. Yeah. Thank you. Have a good day. Ending the stream.